Hello, I am Matklad, and I will start with a tale. So, once upon a time, many years ago, there lived a monk in a monastery in the desert. The monk's name was Pamba. So, one day, Pamba planted a barren tree, a stick really, on the mountainside. And then he tells his very young pupil, Ian Koloff, that he should water the tree every day until the tree blossoms. So Ian Koloff would take a dipper, fill it with water, and then go all the way up to the mountain, water that stick, and after that, when the sun was already down, he came back to the monastery. And he did it every day for straight 3 years. And then one day he came off the mountain and see that the entire tree was in fact in bloom. Say what you will, but a method, a system, has its virtue. So that was the tale. Now the official start of the talk. And this is the last talk of the day, so it's going to be very simple, almost non-technical. And I'm also promising you that you won't learn anything new. Because I only want to trace the implications of two pretty well-known ideas. This is the first idea from software engineering at Google Book, that software engineering is programming integrated over time. Our profession is indeed somewhat unique in that every day we come to our job and we build upon the stuff that we worked on yesterday and the day before that and the last week directly. So what we are doing is that we are building a mountain one grain of sand at a time in a process of anti-erosion. And that is like the first idea. For the second idea, I don't really have a good bon mot like this one, but at the same time, like the idea is that simplicity matters. And a fun fact about this idea is that it is repeated again and again and again in every book, in every article, and really in every single talk about software engineering. Because we started with Hannes speaking about the simplicity of the data lakes, and then we have Dominic speaking to the missing simplicity of distributed programming. Then we have Stephanie about the simplicity of data processing for AI, and then we have Thea with, well, elementary particles, which I guess also is simplicity. Finally, we had Laris, who wanted, as it was written on the slide, simplicity and not just things to be easy. So what we get if we combine these two ideas? Software systems are really a result of iterative process of software development. And it makes sense to make the process itself as simple as possible because that gives you compounding returns. The catch, though, is that you know it when you don't see simplicity. But actually, achieving simplicity is pretty hard. You need to do a lot of work to find fundamental simplicity in what you're doing. So what I'm going to do next is actually just to show a couple of specific things for how we make building TigerBeetle simple. So I hope I don't have to ask about the size of the font here, thanks to the size of the display. To start, we obviously need to clone the repository. So let me do it. And this is actually awkward because I was planning to tell a joke while the repository is getting cloned, but it's already finished. And that's actually like the first example of simplicity. You see, the time to clone repository is a fundamental constant. Every interaction with repository mediated by this time. If a new colleague joins, and the clone repository for the first time, well, they need to wait. If you are debugging some particularly tricky bug and you want to have a fresh checkout, you have to wait this time. If you are a CI server and you need to test the new code, well, you need to clone the repository. It makes sense to expend at least some time trying to keep the size of the repository down. And it is like not really hard. You just want to avoid accidentally committing large files to the repository. So how can we do this? The first idea is to use some kind of a tool here. You know, there is this shell check tool which you can use to lint your bash script. I bet there is an equivalent git check which you can use to prevent large files from getting committed. I even bet that there is a GitHub action which you can add to your CI script in YAML in one line and have it there. But this is not what we do in TigerBeetle. So let me actually show you what we do here. We have this tidy.zig script where we have a bunch of checks. And here we have, well, a test, which does this very simple thing. It shells out to Git to figure out what objects at all are there in the repository, and then it asks for the size of each object, and then warns about everything that is larger than a quarter or a megabyte. And that really does help to keep the size of repository lean. So I want to emphasize two interesting aspects about this check, which speak to fundamental simplicity. First, this is a normal test. The way you run this thing is by saying zig build test. There is nothing special. And that is somewhat unusual, because the first idea here, if you do this kind of check, is to write it in a separate script and then add a dedicated target in your make file, like make repository check or something like that, and then call that from your CI script. But if you think about fundamentals here, what are you trying to do is you want to run some sort of automated check on a repository. And, well, you already have an entry point for that. That is your test suite. And there is no law which says that doing this kind of thing is forbidden. No, you totally can not only write unit tests, but also write tests which check the history of your project. And this is the first lesson. You want to avoid introducing unnecessary entry points. You already have an entry point for writing and running automated checks, and you want to use that for as many checks as you can. OK, so what is the second interesting thing about this check? It is implemented in Zig. And honestly, Zig is probably the second worst programming language to do this. Because like this is shell scripting. We need to call one process, we need to call another process. Ideally, we want to pipe them, and then we need to do some string processing. Doing this in low-level, manually managed programming language is not really pretty. Really, like something like Bash, Python, Node.js, Ruby, Perl, well, not Perl, but all the others would have been a better tool here, really. But we still stick with Zig. Why is that? Well, suppose I write this in Bash. Now I add a new dependency to my system. I add a dependency on a system shell. So now I need to think about differences of Bash on Linux versus macOS versus Windows. And that's just a giant pile of complexity, which you can avoid by sticking to the tool which you already have. And that is your primary language. And for TigerBeetle, that would be Zig. This idea was most brilliantly captured by John Carmack, who said that the best tool for the job is often, not always, but often, is the tool which you already use. OK, so we have our repository. Next, we want to build our code. But for that, we need to change our directory. We need to have our compiler. And here you might be asking two questions. Question number one, if I've just told you that shell scripts are evil, why am I running a shell script? And the second question is, Why I'm running PowerShell on my Mac? Like, am I crazy? This has to do with bootstrapping. So what is the problem we are solving here? We need a certain computational environment to work on our project. We need a compiler. And like traditional way this problem is solved is that you go to your README file and you add something like please run apt-get install Zeek or whatever. And this is another angle where a lot of complexity creeps in, because if you do that, now you need to think about how different operating systems, how different distributions package your language. A more fundamentally simple approach would be to say, hey, this is specific version of compiler which is recommended for building my software. And this is a script you can run to download this particular version of compiler. The only problem there is that, well, what language are you writing the script in? You only can use something which comes pre-installed with your operating system. And that, sadly, has to be a shell. And, well, that would have been fine, except that there isn't a shell which is available on all operating systems by default. On POSIX, you generally expect POSIX SH semantics, but on Windows, there is like PowerShell and CMD exa. And here, like, I will show you a little parallel trick. So that PowerShell script isn't actually a PowerShell script, or rather, it is a PowerShell script, but it also is a POSIX shell script, taking advantage of different command syntax. This is actually a polyglot script, which just dispatches to a platform-specific version of the download script depending on the operating system. And this is like really stupid and like don't do this, but we do find this useful on our CI, where we can run this script independent of the operating system that is running our CI. Okay, so we have our great new Zeek compiler. So we might want to no. I actually want to also time this just in case. Let's build TigerBeetle. And here another curious thing. You see that I'm not typing just plain Zeek. I'm not doing a path lookup to get my compiler. I'm typing /Zeek/Zeek. Why I'm doing that? Well, the thing is, you probably are working more than on one project. And each project needs its own computational environment, and its own slightly different version of a compiler. And the way this problem is traditionally solved is by adding more complexity. So there are things like version managers like NVM or RustUp, which dynamically substitute, say, Rust for a specific version for this folder. There are like higher-level solutions like Docker or Nix shell. But actually, if you think about it, there is like a much more direct way to solve this problem. And that is to just invoke the compiler, which is stored directly in the project's directory. And I'm wondering, Andrew Kelly, are you here? It feels like it's a bug in Zeek. Why is it hanging? Let me try it again, because it should have been much faster. Or otherwise, this is. Yeah. Okay, I messed it up. Okay, let's try to do it again, because again, this is.
Maybe clear the cache.
Yeah, let's just do everything again, because that's another bonus of keeping the size of the repository low, because I know that, hey, I can very cheaply just go and try again. Build, run, okay. OK, now it is going. And yeah, sorry. This is still using Zig 0.13. And this is still using the LLVM backend. So it takes like 10 seconds to compile. And it would be like much, much faster once Zig gains its native backend for ARM64. OK, so we've built our compiler, but our database. Sorry, I'm a compiler engineer. I don't know what I'm doing here. But building for macOS on macOS is kind of like boring. So let's try to build a Windows version of TigerBeetle. And it is going. And you must understand that what is happening right now, that is me building TigerBeetle on macOS host for Windows, is absolutely nothing unusual. This is like a very, very boring thing. Because what is a Windows binary? Well, it is just a pile of bytes on disk, some file. macOS binary is also a sequence of bytes on disk, just a different sequence. And there is absolutely no reason why you need to do some kind of a ritual dance with like cross-compiler and cross-libraries to build Windows version of a binary or macOS. Sadly, the toolchains for most programming languages make it unnecessarily hard to do cross-compilation. They introduce accidental complexity. And Zig is really remarkable in that it reveals the fundamental simplicity of cross-compilation. So let's check that we actually got ourselves a Windows binary. So it says portable executable for Windows, which feels all right. Let's try running it through Wine. OK, it works. Honestly, I feel that the Zig team deserves a round of applause here. Thank you. So Andrew Kelly, you redeemed yourself for the bug before. OK, so with cloned the repository, downloaded compiler, build the software. Now let's run some tests. Actually, no, let's not run some tests. Let's actually run the whole continuous integration test suite. Because this is a good opportunity for me to be more precise, more specific in what I'm meaning by speaking about fundamental simplicity. So if you want to understand me incorrectly, you could think that I'm advising you to never use libraries, to never use tools, to always do everything yourself from scratch, and to go to the forest to live a simple life. But that is not true. What I'm saying is slightly more complicated. I recommend to look at the problem and to try to understand which parts of the problem are fundamental and which are accidental. And whenever you approach solving the problem, you want to focus on revealing fundamental simplicity. So coming back to continuous integration, the common place that the continuous integration is handled is that there is a giant YAML which encodes all the logic required for checking your project. And this YAML is completely impossible to understand. And you can't also run it locally at all. So the only way you could check if your change is working or not is actually submitting a pull request and waiting for slow GitHub runners to finish their job. And that is obviously not good. Well, there is this opposite commonplace. The idea that you write your entire set of CI checks as a task for your build system, like make CI, and then your CI system is just a single line which calls into make CI. This is also incorrect. For TigerBeetle, there are two absolutely critical things for which we do depend willfully on GitHub Actions. Let me show them. So let's open our ci.yaml. And you see that it is, it is not gigantic, but it isn't exactly tiny. So what takes place in this file? And this is mostly this thing. So you see, unfortunately, TigerBeetle is a cross-platform project. We have to support Linux, Windows, and macOS. And those are very different operating systems. One of them isn't POSIX. And for testing, while you can do cross-compilation relatively easily, doing cross-running, doing emulation is prohibitively slow and also usually doesn't give you full fidelity. So you really do want to run your test on a whole menagerie of operating systems, on a whole zoo of different machines. And this is a complicated problem. This is a distributed system which is also heterogeneous. So we are very happy to rely on GitHub Actions implementation of this fundamental complexity of the problem. We are very happy to just specify, hey, I want to run my tests on this set of machines. Of course, I would be more happy if I didn't have to use YAML here, if there was some simpler, more direct way to do this. But OK, I can encode a simple table in YAML. And then for the actual logic, yes, what I do is I just delegate to our CI task in the build system. So this is the first fundamental complexity of CI. You want heterogeneous distributed system. Here is the second part. So besides TigerBeetle with database, we also have a number of language clients for Node, Go, Python, Java, C#. I think that's it for now. There is Ruby in the works. Oh, there's Rust. I lost the count. So there's really a huge variety of the clients. And to test, say, Python client, you obviously need Python interpreter. And you want to run this test on 3 operating systems. So you have an extremely complicated problem. You want to install Python on Windows, Linux, and macOS. And again, this is also part of the fundamental complexity here. And again, here we are happy to use dependency. We are happy to say, hey, let's use actions set up Python so that we don't have to solve this problem ourselves. So again, it is not about indiscriminately slashing and burning everything. It is about identifying which parts of the problem are fundamental, which are accidental, and about relentless pursuit of fundamental simplicity. OK, there is another example to drive this point home about where it's time to write the tools. And that example has to do with our simulation testing. So some of you have probably seen this game we've built a while ago for TigerBeetle Deterministic Simulator, which showcases how our deterministic simulator works for everyone. But of course, this is not what TigerBeetle developers look at when something fails. We have a backend interface for this. So actually, there are 2 versions of the interface. And when we did the first version, we actually weren't able to properly identify the fundamental simplicity. So I want to show you both versions and to show you how you could simplify the system. OK, so let's now look at something interesting, which is TigerBeetle's issue tracker. So we want to look at the issues, and we want the ones offered by TigerBeetle Whopper. Yoran, what does Whopper stands for?
View stamp operation replicator.
View stamp operation replicator. So OK, that is the one version of a system which should alert us about bugs founded by view stamp operation replicator. And you see, it is actually pretty fancy system. So we have an entire GitHub bot with separate account, with nice profile picture. This bot is able to classify failures into whether they were a crash or a liveness failure. It gives us a stack trace. It gives us the logs, although like the output for some reason is jumbled. I believe it also has some fancy logic for determining if two failures are duplicates of each other, but as you see, like they are not really working because like this isn't a bot, this is like a real human. So really, kind of like the system does a lot, but it really doesn't exactly work because what is the main thing you want to get out of this system? You want to be able to reproduce this failure locally so that you can debug it. And if you carefully study the output here, you realize that you can't actually reproduce it. So you see, well, we have commit hash here. Commit hash is certainly required for reproduction. We also have the seed. So we know that, hey, if we pass that seed to our test, it will fail. But we don't actually have the test. Unless you are working with TigerBeetle and intimately know Whopper's interface, you wouldn't be able to like just jump into this issue because there is the instructions for reproduction are incomplete. So that was the one of the system. Now let's see the two of the system, which is this table. Pay attention to what is not here. You see, there is no stack traces. There is no logs. There is no attempts to classify things into liveness failures or crashes. There's really, like at that collider thing, only one bit of information. Is it a passing seed, green color, or is it a failing seed, red color? And that is actually all you need, because the thing is fully deterministically reproducible, and the only missing thing is the command line, and well, it is right there, and you can copy it, and then you can paste it in your shell, and you get your production. And notice how much more information dense this interface is. Previously, we had a whole page for a single issue. Here, in this table, we have a pretty large summary. So we see that on the main branch, we had this failure 6 days ago. But today, our main branch is actually green. So we know that we used to have this failure, and now it is fixed, which was another big problem with system 1, where, like, there is a bunch of failures on our issue tracker, and then we fix some of them, but we don't close all of them because they are like duplicates. OK, so moral of the story. Often, you do not want to use a tool. You want to understand what the tool is doing, and then you want to do that thing that is done by the tool just manually and directly. But also, there are times to write real tools. And when you write real tool, you could save a lot of effort and make tool a lot more useful if you focus on what is fundamental and aggressively get rid of all bells and whistles, which actually are not needed, which make development tool slower, and which actually might make the actual core thing harder to achieve. On the topics of the tools and simplicity, I also want to look at the backend of this backend. So how do we get those seeds? There is a certain fleet of machines which is continuously running this Python setup. So you see, like, this number is that we have 483 whoppers per minute because there's like a lot of machines there. And this system to run those further is, I mean, you see that it's like not going to be trivial because, like, we need to check main branch, we need to check pull requests. There are like various fuzzers. So this code needs to change. And that means that at some point we need to upgrade our fuzzing fleet to new version of the fuzzing infrastructure. So how would you do it? In the first version of the system, I think we implemented it in Go, and we had it in a separate repository, and it was running through systemd. So if you wanted to make a change, you check out the repository, build the system, and then you redeploy it to all of the machines, and then instruct systemd to restart the corresponding service. And again, you could solve this problem by throwing more complexity at it, by doing Kubernetes or whatnot. I'm actually not super familiar with those technologies. But let me show how this problem of deployment and upgrade is solved in the new system. First of all, the system itself is part of the main TigerBeetle repository. There is this cfo.zig script which implements the logic of calling the fuzzers. Again, very horrible use case for Zig. This really would be much better in Python or whatever. But again, we want to avoid introducing a second language to our codebase. Zig is not the best, but it is within 2-3x of Python. And that's not a lot of code. Now, because this is part of the main repository, changing this thing is very easy. I'm just going to send a pull request. I don't have to think about, hey, I now need to check out separate repository and do something there. And this is how we run it. So I'm wondering if anyone recognizes the language which this pattern is coming from. This is actually Erlang. This is the universal server pattern. Because what are we doing here? On machines which run this system, we clone the repository, we download the compiler, just like I showed you today. We build and run the actual system, which does some amount of fuzzing. And then, crucially, we go and loop. So we clone repository again, and we get a fresh copy of the code. That means that to redeploy a change to the whole fleet of my machines, I just need to commit my change to the repository. And then it gets automatically picked up. And this is universal pattern from Erlang. And really, writing this sorts of things in Erlang would be much more enjoyable. But the thing is, again, Erlang is a whole new big ecosystem. It is excellent ecosystem. But because we already have one ecosystem, the Zig one, we would rather avoid depending on Erlang as well. At the same time, we are very respectful about the tools. So, this actually is something I want to echo with what Loris said in his talk, that you might not want to use the tool, but you need to understand how the tool works to be able to apply those same patterns in the code you write. And if you don't write the code, and if you just use the tool, you want to understand how the tool works internally to be able to make informed decisions about which particular flavor of the tool you want to use. OK, so that is the idea. Build tools, build them simply. I want to stop a little bit on this page a bit, because this is another example of a very simple pattern which is very powerful and which I recommend everyone to adapt. And that is, every project should have an internal HTML page. So this is obviously a web page. The source for this web page lives in the main repository. So there is dev-hub index.html, which is very baby HTML, 100 lines of HTML. Even I can write that, maybe even without help of LLM. Sorry, I mean, I'm compiler front-end dev. And there is slightly more JavaScript to power all those tables, but it's also not a huge amount of code. And again, this is JavaScript. This is no TypeScript. There is no build step here. So if I want to hack on this thing, when I will go to the repository, make some change, then just say Python HTTP server, and then I get this thing locally. So I don't know if let's change something. If I want to say hello, Loris, yeah, I just refresh and it is here. So very simple mode of development. And why it is useful? Well, now I have a very low friction to add arbitrary information to my project. So if I want to show the results of the Python runs, well, I can just plop them into that page without talking with the person who maintains some dashboard or whatever. If I want to visualize metrics, again, I just write a tiny amount of JavaScript to do that. And there is also one social engineering tricks with metrics in particular. So the problem with metrics is that it's easy to have them, but it's pretty hard to constantly pay attention to them. So what we do is that we have an information about release manager right here. And every week you worry, am I release manager this week? Should I be worrying? So you go to this page, you notice who is release manager. Oh dear, so I'm release manager. Okay, let's put it on the stack. You notice who is release manager, but you also look at the metrics. And well, I mean, given that I'm a release manager, I think it's time to do a release of TigerBeetle. So let's do a release. Why not? Okay, so for doing releases, we need to go to the root repository. We have a script which generates the changelog, because the changelog is the source of truth for all version information. So here, I need to disable my spell checker, because spell checking is unsolved problem, and it completely breaks copy paste in this not actually that large changelog file. Okay, so what do we have today? We built Rust client in release mode, which is definitely safety and performance, and we do an internal change to the CFO. Okay, I wrote a bad commit message. Let me try to rephrase this. Prioritize more important others in CFO. Did I make a typo there? Is it all right? Okay. And we need a tiger track. So I asked a local person what is the most Amsterdam sounding song, and got this response. Okay, so no, I don't need VS Code. This is the changelog. Release. Insert date. Release. Okay. Okay, commit is there. Let me push it and create a pull request. Can someone from TigerBeetle team please approve this? I mean, okay, thank you, Chaitanya. And at this point, you might be wondering, am I crazy? Because TigerBeetle is a serious business. It's a database for financial transactions, which claims to be highly reliable, highly available. So it is obviously completely irresponsible from me to do a release while I'm worrying about my dog. And the truth is, yes, I do worry a lot about my dog. But I don't worry about the release process, because I know that release process itself is engineered to be simple and to avoid mistakes. And where is Andrew there? So the main trick we use is that we do a release of TigerBeetle every week. And that means that whenever you do a release, the set of changes which go into release is very hot. Like, I mean, I know the tuple requests which will go in this release. So I know that there isn't anything particularly risky there. And I know that, hey, like it is going to be fine. Then, on top of our weekly releases, we have a strict adherence to not rocket science rule, popularized in the Rust ecosystem, that we only advance the tip of a main branch to a particular commit hash once we know that that commit hash passes the full suite of automated checks. So I know that, hey, if this is on main, it is good to release. Finally, and this is kind of like, the most important part here is that our release process is actually two-phase. So what we did just now is that, oh dear, how many approvals. Yeah, so it will be very funny if it actually does introduce some critical bug. Then you will like all be sued. Our release process is two-phase. So what we did right now is that we wrote down the changelog, and by the way, we like don't do this like conventional commit automated changelog or like LLM generated changelog. We do write changelogs by hand, and we usually do way more editing than I did today, because I think like it is important to communicate clearly with your users about the changes. So we did a changelog, and we picked a commit hash, which we deemed worthy to be a release. Now, what will happen next is that this commit will be handled to our C4 infrastructure. And you see, so this is like the first line, release. So that was actually the previous release. Once this is merged, the C4 will be running our fuzzers for this new release. And it will do this until Monday. And then on Monday, the new release manager, DJ, will actually look at what we did today and will make a final judgment call whether it is safe to release the code or not, based on over human judgment, but also based on the amount of passing seeds we will have accumulated by the time on our CFO. So we have 15 minutes left. That means that I probably forgot a couple of points I wanted to make in my talk, but I no longer remember them. So let's wrap it up. I hope you are inspired to go and seek out fundamental simplicity in the systems that you build yourself. Maybe, on Monday you go to your work and you shave 1 second from your build time, or maybe you remove one line from YAML, or maybe you replace some third-party tool with first-party tool. Really, it's like there is no silver bullet. Like, it is all hard work. It is anti-erosion. You need to put effort to keep the process of building systems simply, but this hopefully will be a good inspiration.